Hi, DiffyQ students. Here we are in e-learning. We're looking at the Chapter 4.1, 4.3 review. We're getting prepared for our test, and it's been a while since we've tested to see if answers are linearly independent or linearly dependent. This is from section 4.1. And the Wronskian is used. I'm going to do this quickly. We're going to make videos really by problem. This first video is just going through this first page, problem 1. And we're given two distinct solutions. Perhaps these are the solutions for a differential equation. That is the implication, isn't it? And, we've got y equals sine of 2x, y equals cosine of 2x. We're going to take our derivative. Using the chain rule, we'll get 2 times the cosine of 2x. Here, the derivative of cosine is negative sine, but we need the chain rule, of course. The derivative of that 2x is going to be a 2, so out comes a 2, just like before. And the Wronskian is a determinant. And here we'd have our first y solution. And then down below it, we're going to have our y prime. Likewise, over here, we'll have the cosine of 2x. Underneath, we'll get negative 2 sine of 2x. And we're going to evaluate this Wronskian. If the Wronskian is not 0, then we have linearly independent solutions. So how do we do this? Well, you could use a calculator. We're going to do that next time for the next problem. I'm going to just review how a 2 by 2 determinant can be worked out by hand. It's like cross multiplying. You'd get negative 2 sine squared of 2x. And then, of course, we're going to minus, and then we're going to have this other cross multiplication, a 2 cosine squared of 2x. Well, as you're looking at this, you might think, well, how do I work this out? First of all, realize you may factor out a negative 2 from both of these, and then you'd have the sine squared of 2x plus the cosine squared of 2x. And please realize that one of the most basic identities of all, sine squared of theta plus cosine squared of theta, will always equal 1. And I guess what I'm trying to point out to you is, as long as these arguments right here are the same, sine squared plus cosine squared will always equal 1. What does that mean for us right here? Well, that's negative 2 times a 1 equals negative 2. So we can say, therefore, we have linearly independent solutions. Okay? So as we are looking at this next problem right here, I think you can see already that this is way, way different. You're going to have 3 distinct solutions here. You've got y equals x minus 2. You've got y equals x squared minus a 2x. You also have y equals 3x squared plus x minus 1. And as we take our derivatives, y prime, of course, will be a 1. Y prime here will be a 2x minus 2. Y prime here will be a 6x plus 1. But of course, we're going to have to take a second derivative. As we take that second derivative, we're going to see that the derivative of 1 is 0. The derivative here is just going to be a 2. The second derivative here is just going to get you a 6. So this is going to be our Wronskian determinant. We can see that, we've got our first y solution. It's always going to be a square determinant, same number of rows as columns. So we have an x minus 2, a 1, and then a 0. Here we'll have x squared minus 2x. This first derivative was 2x minus 2, and then we have a 2 here. Then finally we have x squared plus x minus 1. Then we have 6x plus 1, and we have a 6. Now, you are more than welcome, pardon me, we've got to bring this back here. You are more than welcome to evaluate this determinant by hand. That would be a lot more difficult to do. As I suggested at the top, what you can have in the directions is you can use your TI-89. My apologies, my TI-89 emulator is not operating. Obviously, we're away from school, and that emulator link is through the school's file that I pick up on the school internet. And I'm sad to say I can't access that from home right now. That being said, what we'll do all the same is just have a friendly review. Find the DET command on the 89. Hit catalog. Catalog is, if you go to where the 8 button is, and if you go up 2 buttons higher, or 3 buttons higher, I should say, you'll be at catalog. And, then you'll be able to actually hit an alpha D, go to determinant. And what you have to do is start with a left bracket. That left bracket, if you look above the 9 button, there's a comma. But when you hit the second button, that's how you get that left bracket. So all you got to do is type in your first row here. X minus 2, then you hit a comma. The comma is one step above the 9. It's where you found your left bracket, but this time you don't need the second button. And then you just type in an x to the second minus a 2x. And then we'd say comma 3x to the second plus x minus 1. But then you need the semicolon. And guys, the semicolon, if you look right above the 9 in the yellow or a different color, you'll see that's where the semicolon is. Hit second 9 and you will get that. And then just type in your next row. It's a 1, a 2x minus a 2, and then a 6x plus a 1. What do we do next? Well, you're going to need another semicolon. That's where you go second, and then you hit 9. Then finally, guys, you're going to type in your last row, the 0, 2, and the 6. What you're going to have to do is close your bracket, and then you have to close your parenthesis. You need both of those. And when you do type that out, you should get an answer of 26. So that answer of 26 is going to mean that we have linearly independent solutions. What that really means is your two solutions are not multiples of another by some constant, by being able to just come up with trig identities, perhaps find out that you could somehow derive one from another. So that's it for our first problem there. I hope that's working out well for you. Keep plugging away at this. These first two problems aren't so bad. Our next video is going to be a review of how to get a second solution when you were given a first.